Let's talk about slant asymptotes. This is from section 4.2. So a slant asymptote, instead of it being a vertical asymptote or horizontal asymptote, it is something with some kind of a slope on it. Another word for it is an oblique. So if the degree on the numerator is larger than the degree in the denominator, you will have a slant asymptote. Looking at this example here, we have 2 as the degree on top, 1 on the degree on the bottom, and because of that, we know it's a slant. To find out what the equation of the slant is, we need to do long division by dividing the top by the bottom. So if I did that, I'd have x squared minus x, and I'm going to divide that by an x plus 1. When I look at this, x goes into x squared, x times x is x squared, x times 1 is an x, and I'm subtracting all of this. So this cancels. This becomes a minus 2x because this becomes negative if I distribute that negative sign. Now x goes into negative 2x, negative 2 times x is negative 2x, and negative 2 plus 1 is negative 2. I'm going to subtract those. This cancels, and my remainder is a positive 2. Now, in this situation, the remainder means nothing. What I really need to look at is this, x minus 2. That is the equation of my slant. It has a slope of 1 and a y-intercept of negative 2. So this is where they graphed this slant. The other asymptote I have is setting this one equal to 0, and that would make a negative 1, and that is where we got the vertical asymptote. And then if you recall, we go to graph these lines. You can take a tester point on the right side of the vertical asymptote and one on the left side, and you'll know where to place your first dot, and then use the asymptotes as your guide. Let's look at this one. Again, we have a 2 on the top, a 1 on the bottom, so there's definitely a slant. We know that there is a vertical asymptote at x equals 1. Let's divide this into the top polynomial. Oops, let's make a division sign. We have x squared minus x minus 2. So x goes into x squared, x times x is x squared. X times negative 1 is negative x. I'm going to subtract those. And there is absolutely nothing left here. When I subtract them, they become opposite. And so because of that, we have 0. We can bring down the negative 2, but that's my remainder. So my equation of this line is just x. And you see that here. So the y-intercept, if I put 0 in for x, I'm left with just negative 2 over 1 or just 2. So that gives me some kind of a point. And I already talked about the x-intercepts because, the vertical asymptote. The x-intercept are when I set the numerator equal to 0. So that would be x squared minus x minus 2 equal to 0. And if you factor that, that's going to be an x minus 2 and an x plus 1, and set each of those equal to 0. And that's why they got a negative 1 and a 2 here. And I already talked about the vertical asymptote. So looking at my graph, here's my slant going through 0. It has a slope of 1, so it's a rise of 1 and run of 1. And I have my vertical asymptote at 1, and we have a x-intercept here at 2, and we have another x-intercept here at negative 1, and a y-intercept at 2. So I would have just personally just used those 3 points and used the asymptotes as my guide to give an estimate of a graph.